in a particular place like Singapore. Whereas the Global Innovation Network is more about what's going on in that place. Actually, not so much Singapore, but more Taiwan and more South Korea, that is actually producing innovation in a network that in the information and communication technologies industry has control elements in the high value added part, which are not in that place, but nevertheless that place is moving up that innovation network because it's getting involved in innovation. And the old model, as I call it, was mainly focused on the PC and the laptop assembly industry, where Asia, Mexico, peripheral Europe were commodity component suppliers. Memory devices tended to come from Japan, Korea, Taiwan, and Singapore. Hard disk drives, good example. Singapore had located in it Seagate and Western Digital, the two big producers of hard disk drives for all computers of all kinds that are used. And interestingly, Singapore had its own production network around it in Malaysia, Thailand, and the Philippines. And you will have read in the newspapers about the floods in the Philippines and the problems caused to the production of Western consumed PCs and other ICT products because of the floods in the valley, in Thailand actually. An example of how, in a way, one of those elements in the chain actually grew itself out of being simply a production into an innovative element is the Acer group. And some of you may have an Acer computer or laptop or know about it. And that company has 6 manufacturing sites, 2 in China, 1 in the Philippines, 1 in Malaysia, 1 in Mexico. Then it has, as a major global player itself, from Taiwan, starting up as an SME, 19 overseas assembly plants, and eventually, as I've got stuff that could show, but I've left it out today, they bought chunks of IBM's PC network when they sold Lenovo, but lots of the routine assembly parts were bought in factories located in North Carolina, production brought back to Taiwan, and so on. So the story in brief is on the one hand the demise of Western originators of mobile telephony, like Nokia, demise of, by the way. If I was Warren Buffett, I'd say buy Nokia, but most people will sell Nokia shares. Warren Buffett always buys when they're on the way down because he thinks they'll come back up, and sometimes, most of the time, he's right. This time he might be wrong. Now, this is the sort of thing we're talking about. A study in complexity. Just take the backs off your smartphone, so this is what you'll see inside. If it's an early smartphone from the early 2000s, when the global production networks were starting. I think there are 17 elements in this little box, all more or less produced by different companies. Infineon, which is German, used to be Siemens. Infineon at the top. Infineon in the middle, there's 3 Infineons, but then there's Samsung element, and so on and so on and so on. You can imagine the complex nightmare which is achieved daily to integrate these different elements, these 17 different elements in this phone to make it work properly and to actually control the different systems that are involved. So this is, in essence, what we're talking about, and we're talking about simultaneously miniaturization, but we're also talking about this problem of integration and coordination of these different systems so that they can communicate efficiently with each other, and they're all basically continuously being innovated as well. Now, sorry this text is a bit biblical looking, but maybe it's appropriate in the setting that we're in. There's a few others like this. I usually prefer pictures for PowerPoints, but anyway. These are interesting tales that you might capture if you read fast and move down quickly. Sweden was one of the inventors, you could say, in mobile telephony. And Sweden has now lost its last mobile telephone producer. Sony Ericsson announced they were dissolving their partnership about a month ago, and so there'll be no more mobile phones produced by Ericsson. But that part of Ericsson was always a relatively small part, and very much focused on Ericsson's core knowledge, which was in telecommunications. And the bigger part of Ericsson is ST Ericsson, that installs the base by which we communicate with each other, the GSM system in Europe. Now that is under threat. And in the last quarter of last year, that's the bit that was coming into this presentation from the Sunday newspaper, they registered a huge loss of, in the last quarter of last year, some billions. And it was largely because A, market's down, but B, their competition, primarily from a Chinese company you may never have heard of called Huawei, probably the biggest telecoms company in the world, is causing them grief. To the extent that each time an Ericsson plant shuts down or downsizes in Sweden, Huawei move in and buy up the engineers and set up an R&D plant in Stockholm, Gothenburg, and more recently in Malmö. So what's happening, that's a good story, if you like, in Sweden. Well, small, smart startup companies in the apps industry. On the back of your tablet or your smartphone, you know, you've got on the screen, you've got apps. And some companies, some places have good apps producers. They can be individuals working from home, they can be individuals working in an incubator, they can be a small group of people working on apps. This time last year, one of them was bought by Apple for 29 million. One of them was bought by BlackBerry. The Apple one's doing okay, the BlackBerry one's rather worried. In fact, they more or less, they left the company and they've started up, some of them anyway, new companies. Because BlackBerry is another of these companies, really. Research NUIM, the Canadian company that produces BlackBerry, is also in difficulties. As you may know, the founders of the company, Lazaridis and Balsidi, both resigned last month, and the expectation is that someone like Samsung, or could be Apple even, might buy them up, because there are things they've got, like the BlackBerry Messenger service, which are very useful, especially if you're going to have a riot in London. Now then, what happened to Nokia? Maybe some of you think, Nokia? I just bought a Nokia. My Nokia, I'm very happy with my Nokia. Most of you have a Nokia, which is really basically a mobile phone. And in the modern context, the mobile phone is the least interesting part of the smartphone, or the tablet. In fact, I don't think there is a mobile phone in a tablet. Nokia didn't notice really the change in the market, and this is an interesting thing about big firms. And indeed, Nokia, one of those firms that, if you ever read their history, they started off making rubber Wellington boots, as we call them in this part of the world, and they ended up making mobile phones. So they, chameleon-like, they transformed themselves at regular intervals from one thing. They used to make, after they made rubber boots, they used to make cables, electrical cables. They were in the pulp and paper industry. But they didn't notice the smartphone. They kept plugging away with their mobile phone idea, using their own operating system, Symbian, which was produced as a network partnership in Cambridge back in the 80s and 90s. And basically, they've lost huge amounts of market share. They laid off about 1,000 software designers in Finland in the last year, and they were fortunate that 800 of them were picked up by Accenture, one of those computing management consulting companies. They've now announced they're going to reduce their R&D workforce worldwide, Nokia now, by 40%, getting off a half. And I was there the week before last, and I was in TechAce, which is the National Technology Agency, and said, what the hell are we going to do with all these engineers? Are they going to go abroad? Are we going to lose them? They've got an incubator program from which they think they might get about 100 startups, one-person startups. But there's a crisis in Finland, and this is the problem. I was hearing things which I was thinking, yes, but, you know, about specialization. I don't like specialization, and I think Finland's got real problems because it's over-specialized in mobile telephony and over-specialized in one company, indigenous as it may be. And one of the little pieces in the background to this that got into your newspapers was that Nokia, for the first time, is interested in Ireland's IDA model of attracting more diversified foreign investment in, which it has never really done. And then there's this third Nordic country, Denmark, where less well known and less glamorous, the GSM infrastructure was kind of invented in Aalborg, north of Jutland in Denmark. That has eventually, there's a cluster of about 100, 120 firms, essentially closed down. It was bought into by the firms named there, Texas Instruments, Motorola, stripped of its knowledge, and basically hasn't got any new knowledge worth it down, compared to what the Chinese and others in Asia have got. And so it's disappeared. So there's three or maybe four of the key elements of the European Nordic world lead in mobile telephony and what's now developed out of that, smartphones, tablets, all that sort of thing. Essentially finished, I would say. Nokia may bounce back, as you may know. It's formed an agreement with Microsoft, which is really, obviously, an excellent company, but it's a new boy in telephony, whereby they use the Microsoft operating system for the mobile phone, for an Nokia mobile phone, the Lumia. But it hasn't sold very well, and it's not thought to be particularly innovative. Meanwhile, back in dear old Silicon Valley, this is the home of the smartphone. The two main producers of the smartphone technology are Apple, based in Cupertino, right in the heart of Silicon Valley near Palo Alto, and Google, located just down the road. And these two have since, Apple introduced the smartphone, and subsequently whenever it was, last year, I think, or not long ago, the tablet, the iPad, first of all, dominated the global industry. But recently, Google, with its Android, Google's model is, as you may know, again, different business model. Until recently, they didn't have a hardware product. They produced a system. They produced Android, which is used by lots of other companies. Samsung, HCT, Sony Ericsson used it, Motorola used it, and so on and so forth. But recently, Google bought Motorola. Because Motorola, another of the founders of the industry from the US, is also no longer an independent company and is likely to, well, it's owned by Google, but mainly for its patent portfolio. So, but California is important because this is where the high value added, what should we call it, aggregation, design and aggregation of the product and the marketing. And indeed it's where a lot of it, as we've looked at Apple's value recently, it's got more in the bank than the US Treasury, in billions, apparently, available as liquid capital to do something with. It can acquire almost anybody it wants. And Google is next door. And so that old Silicon Valley model isn't over yet by a long chalk. And it's a small part of what happens in this, and what I'm doing is painting a picture of what goes on around the world. Some parts going down, some parts going up. California going up. In Cambridge in the UK, the main supplier of chip designs, not actual chips, but the designs, the software and systems, is ARM, which used to be called Acorn a long time ago. In the UK, lots of kids learnt about computing on a BBC computer. It was an Acorn, and now Acorn became ARM. And they produce these power chips. And these are the crucial technology for two reasons. One, you need more and more power to power up all these 17 and more probably chips in your smartphone or your tablet, but you also need them to be low power users for all sorts of reasons. Batteries, still, that's the weakness in this industry. They don't store enough power. But there's another one, Cambridge Silicon Radio, that was mentioned earlier. I think it was one of the acquirers into the Danish cluster. And then there's companies nobody's ever heard of, like Autonomy, which is one of these software companies, was bought last year by Hewlett-Packard, which is also in crisis, by the way. So beware what might happen in Portland with, Boise with Hewlett-Packard, because they're basically wanting to move out of hardware and more strongly into software and systems, which is where the money is, we'll see later on. Small firms in Cambridge are still being bought by foreign firms for large amounts of money. I mean, Autonomy, 10 billion, that is an enormous amount of money for a small, relatively small startup. And companies like Ubisense that do digital mapping for logistics, improving logistics, which is extremely important in this globalized industry. As we'll see, you'll may hear me say something about 98.2, and I'll pass over it, but I'll tell you what it is now. Apple insists on 98% of its order, which can be for a shipload of chips, to be delivered in 2 days, 98.2. And they go to Taiwan using ARM chips, because Intel, which is just down the road in geographical proximity, is too slow. Think about it. Intel, too slow. Intel still supplies chips for Apple computers, personal computers and laptops, but not for mobile phones. Too slow. Carry on then. Other parts going up, South Korea. And at the other lower element, if you like, of my presentation is these processes are going on in the technological paradigm, but there's often a kind of regime around it, which I refer to in the paper that this talk is helping to construct. Territorial innovation system. It might be regional, it might be national. In this case, in South Korea, it's the national innovation system, which has been extremely important in enabling South Korea to lead the world in the flat screen technology. Large, liquid crystal, now LED, lower energy requirement, or the touch screens on your mobile phone, on your Samsung Galaxy, for example. And the government essentially set up a Samsung platform, I would call it, in a place up near the border with North Korea. Later it's set up with private capital as well. And the capital was both, in both places was local, i.e. Korean, Samsung, and suppliers to Samsung, and national capital. And then it was LG's turn. Now LG has its own kind of platform, and there's a third one for both of them, which they're mentioned as you eyeball this. But essentially, the National Innovation System helped Samsung and then LG, but Samsung particularly, to become a world leader in flat panel display technology. And there's another story behind that, which does have to involve university research, but you'll notice I haven't mentioned any universities yet, because actually in this industry, although universities are important at a point remotely from the kind of wars that are going on that I'm describing, they're not as close as they are in, for example, biotechnology, to the chalk face or the coal face, whichever you prefer. Ireland, by the way, I should, since I'm here, but I should mention it's quite interestingly still, as Rogers was saying earlier on, attracting, even in these difficult times, or perhaps because they're not so difficult from the global innovation network point of view, in software alone. This is my take on data from the IDA for 2011, and I think I did it fairly quickly, and I may have missed a couple out, but there's 2,000 jobs announced last year in software of various kinds. Financial software, but also cloud-related software. I need to go and do some interviews or read more closely to know what that means. Could be server farms, that's quite possible. Could be something more. But it's a mixture of routine back office type stuff and some sort of adaptations, customer relations, programming, and that kind of thing. So what I don't know, but one hazard a guess, is that some of this is fitting into the software and systems requirements of companies like Microsoft, possibly, which is obviously involved in this global innovation network, possibly Apple, and certainly Dell. But Dell aren't such a big player in the smartphone field, they're a computing company. Now we come to Singapore, which is interesting because in a way I think the National Global Production Network is quite influenced by Singapore and the model that I described to you earlier, whereby back in the early 2000s and even in the 90s, deals were made between the National Innovation System, government essentially, and the agencies that support innovation in Singapore, and multinational capital organizations like Seagate. Western Digital, I think Hewlett-Packard also was there, with a focus on hard disk drive technology and some other technologies as well. What I feel now is that production model is gradually being overtaken by an innovation model. So, and I don't know, and Henry will tell us hopefully later today, how much real innovation in the sense of indigenously derived innovation in this technology, its core technology, hard disk drives, or any others connected more to smartphones and tablet computing, which is everyone in the industry says is going to wipe out eventually personal computer as we know it today, let alone the desktop. Large companies are buying tablets in large numbers because the employees in the companies just find them easier to work with and travel around the country with, and travel abroad with, and so on and so forth. So that, in a sense, what we may be seeing in Singapore, and it's a kind of just, which is also very interesting, is the demise of their particular way of being in the production network, bearing in mind that the technology is also changing, so you may not need so much as hard disk drive space because you're storing the data up in the cloud. And here's Taiwan, which is, there are two key innovators joining this global innovation network, and maybe Taiwan is the more important, although Singapore is the bigger in terms of probably certainly the firms and the value created. A company like MediaTek, but there are others too. And MediaTek is interesting because it is supplying now the technology that glues together those 17 different chips by replacing some of them into an integrated, what thing they call a chip stack. And Texas Instruments and Qualcomm and Broadcom, the companies that have hitherto supplied this chip technology to smartphones, Apple especially, can't compete. And so the innovation is in Taiwan, and some companies, notably Detector, some others as well, is actually displacing Western suppliers to Apple and the like. Now, time's getting on, I'm nearly there. Taiwan is advantaged by having across the straits China, and the map on the left, if it is a map, is showing part of Shenzhen, where tons of companies are making various pieces of things, smartphones and other technologies, notably Foxconn. You may have read about because workers have a tendency to suicide in that company. It's a hell of a bloody regime, as Marxman put it, to work under, and we make no bones about that. There are these, therefore, what so-called catching up locations, basically in the Yangtze Delta, the Pearl River Delta, where Shenzhen is, which is the main center of this routine assembly production for all these chips that are really, they have foreign names, but they're all basically produced in these areas. Or these new frontier locations inland, Chengdu being the most noticeable because it frequently pops up as the place that companies like Foxconn are moving to, are not leaving Shenzhen, but adding more production capability, and that's in Sichuan province. And Xi'an and Wuhan are others. And what you get, and I'm getting close to the end now, is what is known as the smiling curve of value in the ICT Global Innovation Network Territorial Innovation System. The value is up the left-hand side, and at the top are the producers of the designs, the so-called fabless. There's no factory. The factory's in Taiwan. The design is in Cambridge. On the one side, and then nearby in value terms are the apps producers, the companies based in Silicon Valley. There's 200 of them in London, a place called Silicon Roundabout in East London, Toronto, Malmo, places like that. Then you have the third level producers like India, Ireland, and Israel doing different elements of something to do with network architecture for these kinds of systems. And then you get down to the low value adding but highly labor intensive, or at the moment highly labor intensive. Foxconn employs, or will employ, its new factory in Chengdu opens 1.2 million people, think about it, 1.2 million people in 2 factories. Yeah, I know. Unbelievable, check it. And then the electronic, the bog standard electronic, they receive the requirements by fax or by email, and they just produce. And then you go back at the other side of the value, the flagship innovators, the Apples, the Googles, the companies in Silicon Valley, to some extent even some of the South Korean, Samsung and so on, and HTC in mobile telephony. Singapore is higher up in that side. That's the sort of marketing side of the value chain. And the ambition of the companies, and Singapore and more recently South Korea and Taiwan have sort of done it, is to get away from the bottom end of the curve and towards the top end of the curve, obviously, which creates more grief for those who are already up the top, such as the Nokias, or were at the top, Nokias, Sony Ericssons, and the like. So, the question would be, will global production networks like that which Singapore characterizes survive? Will the upper corners of the smiling curve turn down? Will the present leaders, will Apple be displaced by Samsung or HTC or someone we don't know about? Is Nokia finished? Interesting question, the jury's out on that one. These territorial innovation system assistance programs to companies in South Korea and Taiwan have been quite successful. Increasingly China will do this, and that's gorilla, as it were, 800 pounds or even bigger, on the doorstep. State aids have been crucial in the past to the abilities of these economies to develop in the ways that we're talking about, to very sophisticated production and innovation capabilities. Does this model apply in the other industries that are globalized, like textiles, auto, pharmaceuticals? And finally, one of the things I think theoretically is interesting is these places are able to work with what's called the modularization model, which connect, and this may also be found in these other industries. In a sense, it started in the car industry, but it's migrated to the ICT industry. Notice on the left very quickly, this is the last slide, Apple's smartphone. Apple acquired all these companies. The only one which had a close connection to the university was Siri at the bottom, the one whereby you have a conversation with your smartphone these days. That came out of Stanford University. Microsoft Kinect gaming device came out of its own indigenous research in these 6 research centres. Maybe there are only 5 there, they got 6, but one of them wasn't involved. And they weren't working on the Kinect game at the beginning, they were working on other things, human-computer interfaces. And out of this come certain discoveries which evolve into solutions to a problem of how can we have better looking cartoons in our games, more lifelike. And one of the problems that computers have is they can't recognize things that we can, like how a body moves. We know, because we've seen bodies for all our lives, but computers haven't. So this skeleton technology that's mentioned somewhere there was like a kind of breakthrough for this game. And this game has sold 18 million copies in the last 2 years. So this is an extremely important area of the market that people like me talk about, but I don't know anything about it, really. I don't know what Kinect does. I mean, I played with a Wii once, pretending to hit the tennis ball and beat Kevin Morgan in a game in somebody else's front room, but that's about the end of it. And that's the end of my talk.
Okay, we've got time for a couple of questions. So, getting